The Utilysys MDMR education sessions consist of the following 5 sessions. Session 1, USDP Interface. Session 2, Synchronization Interface. Session 3, Daily Reads Processes. Session 4, Billing Quantities Interface. Session 5, Testing and Cutover. Utilysys is proud to present Mike Strano as a facilitator of the MDMR education sessions. Mike is a senior business process design analyst at Utilysys and offers over 15 years of experience in the utility industry. The MDMR is a central repository for storing and managing all smart meter data in Ontario. The MDMR processes meter reads and provides LDCs with billing quantity data that aligns with the time of use rates.
Utilysys would like to provide you with a bit of a functional overview of how the MDMR will work, all the benefits that you will receive from this system, as well as some of the things that you will need to overcome, such as the storage of operational data, which is a function that the MDMR in today's environment does not provide for you. So utilities that are looking to use their AMI data to facilitate smart grid functions perhaps in the near future will need to think about how to store this data in other systems apart from the MDMR. So this is one of the things that we would like to hit on a little bit in the first session. There are some of the functions that MDMR will provide, and by process of elimination you will see that some of the things that you may have expected might not be there in today's environment. And this is the reason that some utilities will have procured what are called operational data storage systems. And so this is serves as a bit of a reminder as to why you may have purchased that system. Some of the people attending the sessions may not have been involved in that decision and may be wondering exactly what the system's all about. So we're trying to clear that up a little bit in the first session, the data flow, how these different systems will be integrated together. These slides, for the most part through our education sessions, are labeled down in the bottom right corner for where the source of that information was, so that you can refer to the specifications if you're looking for more information. The slides as well have been constructed around the idea that the people watching the presentations understand the requirements for MDMR and AMI, and should you require any additional information from Utilysys, we can provide that, but these presentations do not go into the justification for these systems. On-site education sessions that we would like to provide around business process, we will also get into much more detailed explanations of things like validation of data and how AMI data can create, in some cases, perhaps unexpected results, and how these scenarios would be handled by the utilities. So the education sessions and the presentations that you're perhaps watching or seeing for the first time should serve as an introduction, and certainly not our entire service that we're trying to provide to help utilities get ready for the MDMR.
In order for the MDMR to process billing quantities, several processes are required first. In the USDP request and response process, the utility requests and receives a universal SDP from the MDMR to correspond with each of the LDC's SDP identifiers. In the synchronization process, the LDC submits attributes and relationships to describe the SDP to the MDMR. There are 2 methods of synchronization. The periodic audit synchronization, or PSync, is a batch load of the current state of all SDPs. The incremental synchronization, or iSync, provides daily changes to SDPs. These first 2 processes define the USDP in the MDMR before meter reads can be submitted and processed and stored for billing purposes. When meter reads are submitted from the LDC's AMCC, the files are validated by the MDMR to ensure that they conform with the structure and content requirements. Once the meter read files pass the initial validation checks, the MDMR performs V processing to validate each interval and estimate any missing intervals. When all intervals are populated with valid data, the intervals can be framed into specific time of use bins based on the framing structure defined through synchronization. The result of framing is the creation of daily billing quantities. The LDC submits a billing quantity request for an SDP, and the MDMR provides the data in a billing quantity response along with the transaction codes to describe the quality of the billing data. This diagram shows the configuration employed by the majority of utilities in Ontario. The Advanced Meter and Control Computer, or AMCC, submits daily meter reads to both the MDMR and the Operational Data Store, or ODS. The Customer Information and Billing System, or CIS, submits USDP and billing requests to the MDMR and receives and responses. The CIS keeps all systems synchronized through regular transmissions of sync files. The MDMR transmits interface, billing, data collection, and validation reports to the CIS, which passes along the reports onto the ODS. Alternatively, the LDC can opt to have the MDMR send data collection and validation reports directly to the ODS. Resolutions to meter read exceptions are transmitted from the ODS through the CIS to the MDMR. The MDMR receives and transmits all files through the AS2 protocol of the File Transfer Service, or FTS, which provides a secure transport method. To receive files from the MDMR, the utility is required to have an AS2 client. The utility may submit files between the AMCC, CIS, and ODS using the AS2 or the SFTP, Secure File Transfer Protocol. Regardless of the utility's configuration, there are some underlying rules. Only two parties can submit AMI data for any SDP, and BQ request files must be provided to the party that sent the BQ request file. In this configuration, the ODS acts as an AMI operator and submits all meter reads to the MDMR. The AMCC does not interface directly with the MDMR. The functional requirements of the MDMR are maintained through this configuration. Only two parties can submit AMI data for any SDP, and BQ request files must be provided to the party that sent the BQ request file. In this configuration, the ODS acts as a billing agent. The ODS interfaces with the MDMR for the USDP request and responses, billing quantities, request and responses, and synchronization. As in the standard configuration, the AMCC submits meter reads to both the MDMR and the ODS. The functional requirements of the MDMR are maintained through this configuration. Only two parties can submit AMI data for any SDP, and BQ request files must be provided to the party that sent the BQ request file. These last two configurations, while less common, have been used by some utilities in an effort to minimize programming changes to the CIS. This concludes the introduction to the Utilisys education sessions. We hope that this video has provided you with a high-level overview of the MDMR. In the next module, Utilisys provides specifics on the first MDMR interface, USDP request and response.